Okay, on number 1, let me read it for you. A tennis ball traveling at 10 meters per second is returned by Venus Williams. It leaves her racket with a speed of 36 meters per second in the opposite direction from which it came. What is the change in momentum of the tennis ball? And B, if the 0.06 kilogram ball is in contact with the racket for 0.02 seconds, with what average force has Venus hit the ball? All right, so we are looking for change in momentum. And change in momentum is given by the final momentum minus the initial momentum. So this P subscript of F, that means final momentum. P subscript of 0, that's initial momentum. And I'm going to expand it out a little more here. What's our formula for momentum? Momentum equals that's one way we can find it. Force times the change in time. No, it's going to be mass times velocity. So when we're looking for the final momentum here, we're going to look at the mass of the object times its final velocity. That'll give us final momentum minus the mass of the object times its initial velocity.
So is that P?
A subscript of F and a subscript of 0.
Okay.
In that.
And then what was the V? So that's
Subscript of F, subscript of 0. Okay, let's plug in. What is the mass of our object? .06 kilograms. And the final velocity of the object? Here, let's draw a picture of the situation. It's always best to draw a picture of the situation. So here's Venus's racket. And here's the velocity vector for the ball coming in. Here's the velocity vector for the ball going out. So the ball comes in at what velocity? .10 meters per second. And it leaves her racket with a speed of 36 meters per second. Yesterday, I told you to draw pictures, diagrams with your problem, so you can tell that one of these velocities is going to have an opposite sign. So in this case, let's give the 10 a negative sign. They're in opposite directions, so we have to make one of them have a negative value. Okay, now back over here to our problem. What we're trying to find is the final momentum. The final momentum is the mass of the object times its final velocity. What is its final velocity? .36 meters per second. And we're going to subtract from that the mass of the object times its initial velocity. So that's going to be 0.06 kilograms times, what's the initial velocity? negative 10 meters per second. Okay? You should see here 0.06 times negative 10 meters per second. It ran off the board there. Okay, so 0.06 times 36 meters per second. If you multiply those together, you get 2.16. The SI unit for momentum is kilogram meters per second minus 0.06 times negative 10 meters per second, and you get a negative 0.6 kilogram meters per second. Okay. Here we have minus a negative number, so we add them. 2.16 plus 0.6, and that is 2.76 kilogram meters per second. And that is our change in momentum of the tennis ball. So that answers part A. What is the change in momentum of the tennis ball? Okay, part B. If the 0.06 kilogram ball is in contact with the racket for 0.02 seconds, there's a time, with what average force has Venus hit the ball? Did we learn a formula that included force and time? The impulse formula. Remember, impulse is force times the change in time? Okay, and we saw yesterday that impulse is the same thing as momentum. So impulse equals momentum. So we can use that impulse formula, force times the change in time, and we can use our delta momentum here, our change in momentum here, to find time. So if impulse equals force times the change in time, how would we solve for force? Yep, we divide out the change in time. So force is going to be given by impulse, which is the same thing as momentum, divided by the change in time. So let's plug that in here. Force is given by 2.76 kilogram meters per second divided by, what's our change in time? .02 seconds. What happens with this unit? We have a kilogram meters per second divided by seconds. In this case, they don't cancel. They combine together in the denominator. So we'll end up with kilogram meters over seconds squared. 2.76 divided by 0.02, and you get 138. What is a kilogram meter per second squared? A newton. So we get 138 newtons. And what were we looking for? What variable? Force. So it's a good thing we got newtons. Okay. Number 1 is just like number 3, or number 3 is just like number 1. So whenever you're trying to do number 3, just follow this system of equations here. Let's look at number 2. Well, I'm not going to read it for you. I'll just give you the formula. Number 2 is like what we did yesterday. The only difference is that in number 2, they start out attached together. So we have the mass of object 1 plus the mass of object 2 times their initial velocity is equal to the mass of object 1 times the final velocity of object 1 plus the mass of object 2 times the final velocity of object 2. Okay, number 4 is just like example D, and here's the formula you're going to use. The mass of 1 times the initial velocity of 1 plus the mass of 2 times the initial velocity of 2 is equal to the mass of 1 plus the mass of 2 times the final velocity of 2. I'm going to take this from you on Friday, so you have a couple days to work on it.